Bismillahirrahmanirrahim. Welcome back, my dear students, for this lesson number 2 of the module 9, acids and bases. In this lesson, we will learn how to calculate the pH and pOH, and oppositely how to calculate hydrogen ion concentration and hydroxyl ion concentration by solving some problems of these modules. Acid-base properties of water. As in the previous lecture, I already shown you that water is a special chemical. It have hydrogen ion that act as acid, and it also have the hydroxyl ion that can act as a base. So water have both the property acid and base, so it is called amphoteric. Amphoteric means it have both property acidic and basic. And water is highly reactive chemical. It reacts with everything, almost everything. If nothing is available, then water will react with the water. So this is water molecule. It will react with another water molecule and produce hydronium ion and hydroxyl ions, again acid and base. This is acid and this is base. That is called auto-ionization. Auto-ionization means water will react with the water and produce acid and base. Both will be equal. So if both are equal in quantity, so the water will be neutral. That is why the pure water is neutral. You cannot detect how much acid or base is there. It is neutral. So this is chemical equation. By the chemical equation, here is explain you water react with another water. One water molecule will act as an acid, another water molecule will act as a base, and one water molecule will take the hydrogen ion. When it take the hydrogen ion, this becomes the acid, and other water molecule will give the hydrogen ion, so this will call conjugated base. So when hydrogen ion is there, we measure the pH. We measure the pH by this pH meter, and this pH meter you have used in the lab also. So this pH meter tells you how much is the pH of the solution. These are the examples of the solutions, and the pH values are given. And mathematically you can also calculate the pH by this equation. pH is equal to negative log of hydrogen ion. And for the base, you can calculate the pOH by negative log of hydroxyl ion. So there is a relationship between pH and pOH. The measurement is by machine and by mathematics, both you can do. And after you make a chart of the complete range of pH and pOH, you will find some relationship between pH and pOH. The pH ranges from 0 to 14. 0 to 14. And from 0 to 6.9 it will be acidic, and from 7.1 to 14 it will be basic. Only the 7 will be neutral. Only 7 will be neutral. The red color here indicates the acidic media. The blue color here indicates the basic media. So when you make the list of pH, it will be from 0 to 14, and when you make the in front of this, you make the list of pOH, it will be also from 0 to 14 but upside down. So when you say the pH increases in this direction, pH increases, the pOH will decrease. Same is the relationship between the hydrogen ion concentration and hydroxyl ion concentration. If the hydrogen ion increases in the solution, then hydroxyl ion will decrease the concentration in the solution. This relationship mathematically we can say like this: when you make the total of pH and pOH in any pair, suppose you make this pair, make the total will be 14. If you make the total of this pair, so total will be 14. So this is shown here by this formula: pH plus pOH will always be equal to 14. So see here, pH is 12 and pOH is 2, total is 14. Any pair you take, total will be 14. Similarly, the relationship between hydrogen ion and hydroxyl ion is also turns into a constant. So when you suppose you take this example, this is OH concentration, and this is hydrogen ion concentration, and this is hydroxyl ion concentration. Multiply with each other, it will give you the 1 into 10 raised to the power minus 4. So H multiplied by OH will always give you 1 into 10 raised to the power minus 4, and this is called Kw. Kw means dissociation constant of water. So this is the complete chart, complete range of pH, and some examples are also given here. You can see the examples here, and complete range of pH, and the relationship between the pH and pOH is here, total 14, that is constant also, and the relationship between the H and OH is also a constant, Kw, that is 1 into 10 to the power minus 14. So these relationship are also given here, this case here. So Kw is dissociation constant of water, this W means water, and it is also called ionic product constant, that is Kw, same thing. Value is 1 into 10 to the power minus 4, and when you make the total of pH and pOH, answer will be 14, and that is called pKw. P means minus log. If you say P, then it will be equal to minus log. So if you say the pH, so it will be equal to minus log of hydrogen ion concentration. If you say pOH, then it will be minus log of hydroxyl ion. When you say pKw, then it will be equal to pH plus pOH. So if the hydrogen ion is more, the solution is acidic. If the hydrogen ion is less, the solution is basic. If hydrogen and hydroxyl ion both are equal, then it is neutral. So these are the formula for calculation. In this equation, the water as a pure liquid you have to remove. When you remove it, then product upon reactant, this water will be removed. So this will be the dissociation constant of water, and that will be equal to 1 into 10 raised to the power minus 14 constant. Okay, so I hope you understand all these formulas and calculation and relationship between the pH and pOH. So we can proceed to the solution of the problems. So here in 15.2 he is asking calculate the concentration of the hydrogen ion, and hydroxyl ion is given, that is 0.0025. So we can easily calculate by this formula, that is Kw is equal to 1 into 10 raised to the power minus 14 is equal to H plus multiplied by OH minus concentration. Bracket means molar concentration. So here question is H plus. So H plus will be equal to 1 into 10 raised to the power minus 14 divided by OH. The OH is 0.0025. So answer will be equal to 4 into 10 raised to the power minus 12 m molarity because this is equal to H plus concentration. Okay. Similarly here, calculate the concentration of OH. This time is asking to calculate the OH and is giving you the HCl. HCl means this H ion concentration. So similarly we say here H plus multiplied by OH minus is equal to constant 1 into 10 raised to the power minus 14. The question here OH, so OH will be equal to 1 into 10 raised to the power minus 14 divided by the hydrogen ion concentration is 1.3, so this will be equal to 7.7 10 raised to the power minus 15. 7.7 into 10 raised to the power minus 15 molarity. This is the concentration of hydrogen ion. Now the second example, the concentration of hydrogen ion in the solution was here. This was the concentration of hydrogen ion. Only half of the solution was consumed and half was remained. After opening the bottle was found the hydrogen ion concentration is equal to this. This is after the opening the bottle. So first, before opening the bottle, the concentration was this, and after opening the bottle, the concentration was this. And calculate the pH of the solution for both before and after. So we can divide this question into two. So we say before the concentration of hydrogen ion is 3.2 minus 4, and he's asking you calculate the pH. So formula of the pH will be equal to pH is equal to minus log hydrogen ion concentration. So minus log is equal to 3.2 into 10 raised to the power minus 4. So the pH will be equal to, the answer pH is equal to 3.49. And after opening the bottle after 1 month, so again formula is same, pH is equal to negative log hydrogen ion concentration, so minus log 1 into 10 raised to the power minus 3. So pH will be equal to 3. So before the pH was 3.49 and after it was 3. So this is high. After it become high pH, highly acidic. This is more acidic. After opening the bottle, this will be more acidic. So practice here. The nitric acid is given here, and he is asking you concentration of nitric acid is this 0.76. So same formula. So we have this nitric acid means the hydrogen ion concentration, because nitric acid is strong acid, 100% dissociate. So concentration of nitric acid means concentration of hydrogen ion. So minus log 0.76. So pH will be equal to 0.12. This is highly acidic. This is highly acidic because it's nitric acid is already strong acid. So now this is here another question 15.4. It says about the rainwater. The rainwater collected, and then the pH is 4.82. Calculate the hydrogen ion concentration. To calculate the hydrogen ion concentration, we have to reverse the formula of pH. So what is the formula of pH? Again we have to see pH is equal to negative log of hydrogen ion concentration. If you inverse this and calculate the hydrogen ion equation, hydrogen ion concentration, so this will be equal to, you can say either you say 10 raised to the power minus pH. This formula you can use, yes. Another formula which you can use is that hydrogen ion concentration is equal to shift log. It depends on your calculator, which calculator you are using. So you can use this, or you can use the shift log also. Shift log means antilog minus pH. So this is here shift log minus pH is 4.82. So hydrogen ion concentration will be 1.5 into 10 raised to the power minus 5 molar. Okay, now this, instead of rainwater, he is taking the orange juice. Orange juice is acidic, and this is the pH, and he is asking you calculate the hydrogen ion concentration. So hydrogen ion concentration will be equal to shift log minus pH minus 3.33. So answer will be 4.7 into 10 raised to the power minus 4 molarity, because this is hydrogen ion concentration, this is equal to hydrogen ion. So next problem here, he is giving you sodium hydroxide, this is base, he is giving you the OH and asking you calculate the pH. So it is very easy again, 15.5. okay, so first we'll calculate the pOH here. So because this is base, so we'll calculate the pOH is equal to minus log hydroxyl ion. So minus log 2.9 into 10 raised to the power minus 4. So answer will be 3.54 pOH 3.54. So then we can calculate the pH by this formula, pH plus pOH is equal to 14. We want to calculate the pH, so pH will be equal to 14 minus pOH. So 14 minus this answer 3.54, so it will be equal to 10.46. this is pH answer. Okay, so again now the simple question, OH concentration of the blood sample. So blood sample have the this concentration of OH 2.5. blood is slightly thing basic, yeah. So we calculate the pOH is equal to negative log hydroxyl ion, so negative log of 2.5 into 10 raised to the power minus 7. So pOH will be equal to yeah, here again I don't have the answer here how much will be the answer, but you calculate it and then you use this formula, pH plus pOH is equal to 14. The question, what is the pH? Question is the pH, so pH will be equal to 14 minus this answer, bring it here, and this answer will come here. Let me show you, this answer will come here, this place, and make the minus, some number will come here, and then this will be equal to the answer 7.4. okay, so this will be the pH. Use the calculator and find the answer. Okay, the next question here, this is 15.6, and he is asking you the calculate the pH of hydrochloric acid solution 1 into 10 power minus 3. This is very easy. So but let me show you the HCl, the situation here, because the next class we will learn about the strong acid and strong base, there it will help us. So we take this is HCl, when it dissociate, or you add, when it dissociate in water, so add, put in the water, so it will dissociate into H3O positive and chloride negative. So in the beginning we say time is equal to 0. This will be the concentration 1 into 10 raised to the power minus 3 molarity, that is given in the question here. This is the concentration. So water, because water is a pure liquid, so we are not taking into consideration. Okay, remove it. And hydroxyl hydronium ion will be 0 in the beginning, it will be not produced, and chloride ion will also be not produced, it will be 0. After some passage of time at the equilibrium, it will be finished. The hydrochloric acid will be finished, and completely 100% it will change into hydronium ion and chloride ion. 100% change means this concentration 1 into 10 to the power minus 3 will come here into product. So 1 into 10 to the power minus 3 molarity, and chloride is also 1 into 10 to the power minus 3 because both are in equal ratio. This is 1 mole and this also 1 mole, so both will be the same. So this is the concentration of hydrogen ion, or you can say hydronium ion. So this concentration we can use in the calculation. So now we can calculate the pH is equal to negative log hydrogen ion or the hydronium ion. This is same thing. So that will be equal to minus log 1 into 10 to the power minus 3. So that is equal to 3. So the pH will be equal to 3. So here I mean to say that if the acid's name is given, you have to check this is strong or base. If that is strong acid, so a strong acid will completely dissociate and produce the hydrogen ion. So that's why we up till now we were doing directly that when is HCl is given, the concentration of HCl means the concentration of hydrogen ion, both are the same because it is 100% converted into product. So now this other example here, which is barium hydroxide, this is also the same. Part 2 is about barium hydroxide. This barium hydroxide, BaOH twice. So when it will dissociate into barium 2 plus ion and 2 ions of hydroxide negative. So when say time is 0 means in the beginning initially the concentration of barium hydroxide was 0.02 molar and barium ion was 0, hydroxyl ion was 0, and as the time passes system becomes at equilibrium. So we say at equilibrium it will be finished and change to 100% to the barium ion, that is 0.02, but hydroxyl ion is because of this is 2 double, so this will be multiplied by 2. 0.02 will be equal to 0.04 molar concentration of hydroxyl ion. Then we have to calculate the pOH. pOH will be equal to minus log hydroxyl ion. So this is minus log 0.04 and that pOH will be equal to how much? 1 minute. 1.4. 1.4. Then you can calculate the pH by this formula. pH plus pOH is equal to 14. Your question is pH. So pH will be equal to 14 minus OH, and that is will be equal to 14 minus 1.4, and that is your answer, that is 12.6. This is the pH. So these have 2 steps more than the previous question, because here he was giving the HCl, so direct is asking pH, but here is giving the barium hydroxide, that is base, and asking the pH, so we have to make 14 minus. So similarly this question here, calculate the pH here again. So same we will write here, this is the barium hydroxide, dissociate into barium ion and hydroxyl ion. So when the time is 0, it will be 1 into 1.8 into 10 raised to the power minus 2. So barium will be 0, not produced in the beginning, hydroxyl will be 0, and after the passage of time when the system come to equilibrium, so we say at equilibrium this will be finished, and this will be 1.8 into 10 raised to the power minus 2. This is not our question, but the hydroxyl, yes, this is 2 hydroxide here, 2 hydroxide, don't forget. Yeah, so 2 multiply by 1.8 into 10 raised to the power minus 2, and that will be equal to how much? 0.036, 0.036 molar concentration. So now we get the hydroxyl ion concentration in this situation. This hydroxyl concentration is this one, 0.036. So we can calculate the POH first. So POH will be equal to minus log hydroxyl ion concentration, POH minus, so that is minus log 0.036. so POH is equal to 1.44. Then we have to calculate the pH. So we use this formula, pH plus POH is equal to 14. So pH is equal to, our question is the pH is equal to 14 minus 1.44, and that is equal to 12.56. Our answer 12.56. Okay, so let me check what is the next. Yeah, next is the other thing. So I hope you understand this calculation of strong acid and strong base, and this is easy. Only you need to use the formula and properly use the calculator, shift log or inverse log, whatever options available in your calculator, that you have to take care.